So here's an example question, and it says a die is tossed twice. What is the probability of obtaining A, a 3, then a 6, B, a 2, then a 4, and C, two fives? So let's look at case A. So it's saying in the first toss, we get a 3, and the second toss, we get a 6. What's the probability of having this as our result? They're saying what's the probability of getting a 3, and then in the second toss, getting a 6. Now, when you toss a die twice, the outcome of the first toss is independent of the outcome of the second toss. They have no influence on each other. So these are independent events. Now, the probability of getting a 3 and a 6 is therefore probability of getting a 3 times the probability of getting a 6, because the outcomes of the first and second toss are independent. So the probability of getting a 3 in the first toss is independent of that of getting a 6 in the second toss. So these two outcomes are independent. So let's call them events, are independent. And as a result, the probability of getting a 3 and a 6 is equal to, well, let's put it this way. If you have two events A and B that are independent, probability of event A and B, getting event A and B is equal to the probability of event A times probability of event B. I can write this as A and B is equal to the same thing, which is what we have here. The probability of getting a 3 and a 6 is equal to the probability of getting a 3 times the probability of getting a 6. So this represents the first toss, second toss result. The probability of getting a 3 when you toss a die is just 1 over 6. The probability of getting a 6 is also 1 over 6. Remember, there's 6 possible outcomes, and there's only one way of getting a 3. There's only one way of getting a 6. Hence this. So the result is simply 1 over 36. Question B says probability of getting a 2 and a 4. So now switch to this symbol, which represents intersection or and. The probability of getting a 2 and a 4 is equal to the probability of getting a 2 in the first toss times the probability of getting a 4 in the second toss, which is also 1 over 6 times 1 over 6, which is 1 over 36. Finally, the probability of getting two fives. So getting a 5 and then getting a 5. Again, that's equal to probability of getting a 5 in the first toss times the probability of getting a 5 in the second toss, which is equal to 1 over 6 times 1 over 6, because the probability of getting a 5 is 1 over 6, because there's only one way of getting a 5 out of 6 possible outcomes. So it gives 1 over 36. In case anyone is confused, I'll just show the outcomes of a die toss. You can get 1, you can get 2, 3, 4, 5, and 6. The probability of getting a 1 is simply 1 out of the 6 outcomes. The probability of getting a 2 is simply, well, there's only one way of getting a 2, so it's 1 out of the total number of outcomes, which is 6. The probability of getting any of the outcomes is just 1 over 6 for a die toss, a single die toss, hence the result. So the probability of each of these, of getting any of these numbers was just 1 over 6. So all the answers to this question are the same. Now imagine I ask a different question. So imagine I ask for the probability of getting a 2 and a 5. In the other case, I was asking for the probability of getting a result, then getting a result. Now I'm just saying, what's the probability of getting a 2 and a 5? So I tossed a die twice. What's the probability of getting a 2 and a 5? Now let's look at the possible outcomes of the first toss. You can get a 1, you can get 2, you can get 3, you can get 4, you can get 5, you can get 6. For the second toss, your possible outcomes are 1, 2, 3, 4, 5, and 6. So what's the probability of getting a 2 and a 5? So this time I'm not specifying the order. Well, you can get a 2 in the first toss and you can get a 5 in the second toss, and in that way you've gotten 2 and a 5. Or you can get a 5 in the first toss and you can get 2 in the second toss, and that way again you've gotten a 2 and a 5. So the probability of getting a 2 and a 5 in this case is simply equal to the number of ways you can get a 2 and a 5, which is 2 ways. This is one way, this is one way, this is another way. So 2 ways divided by the total number of outcomes. Now, what are the total number of outcomes? Well, let's list them. In your first toss, if you get a 1, you can get a 1 and you can get any of these 6 outcomes for the second toss. So you can get 1 and 1. Let me list them. You can get 1 and 1. You can get 1 and 1. You can get 1 and 2. You can get 1 and 3. You can get 1 and 4. You can get 1 and 5. You can get 1 and 6. You can also get 2 in your first toss, and you can get 1. You can get 2 and 2. You can get 2 and 3. You can get 2 and 4. You can get 2 and 5. You can get 2 and 6. And the same applies when you have a 3 in the first toss. You can get 3 and 1, and so on. You can get. So where I'm going is that you can get basically 6 plus 6 plus 6 plus 6 plus 6 plus 6, which is 6 times 6. You have 36 possible outcomes. If you follow this pattern, you'll find that when you have a 3 as your result in the first toss, you can get any of the other 6 outcomes in your second toss. Same thing for when you go 4, 5, and 6. What this adds up to is 36 possible different outcomes, where we're talking about where each outcome represents a value for the first toss and a value for the second toss. So here, getting 1 in the first toss and getting 1 in the second toss is an outcome. Getting 1 in the first toss and 2 in the second toss is another outcome. So if you continue like that, you find that you have 36 outcomes in total. So the probability of getting a 2 and a 5 in any order, that's basically what this question is saying, is 2 divided by the total number of outcomes, 36, which is 1 divided by 18. I'm comparing this to the case where I'm saying probability of getting a 2 and then, let's put it 2, then a 5. So you're saying you're getting a 2 in the first case. Let's do it this way. You're getting a 2 in the first case and then a 5 in the second case. Now, there's only one way of that, where you get a 2 in the, well, that's this here anyway. Getting a 2 in the first case and a 5 in the second case out of 36 possibilities. So the probability is simply 1 over 36. And if you recall from my solution to that example where I used the formula, you find that the result was also 1 over 36. So just for the sake of completion, I'm going to list out all the possible outcomes just in case anyone is sort of confused by what I'm doing here. So I'm just listing out all the possible outcomes. So here is saying, this outcome is saying I get a 5 in the first toss and I get a 2 in the second toss. 5 in the first toss and 3 in the second toss. 5 in the first toss and 4 in the second toss. 5 after the first toss and 5 after the second toss. 5 after the first toss and 6 after the second toss. 6 and 1. Okay, 6 and 2. 6 and 3. 6 in the first toss and 4 in the second toss. 6 in the first toss and 5, 6 and 6. And if you count all the individual outcomes, you find that there are 36 in total. Here, this is an outcome and just says I get a 1 in the first toss and a 3 in the second toss. This is another outcome. So you count the outcomes and you find that 36 in total. So the probability of getting a 2 and a 5 is just simply equal to the number of ways you can get a 2 and a 5. Well, here's one way. Getting 2 in the first toss and a 5 in the second toss. And, so I'll shade that. And here's another way. Getting a 5 in the first toss and a 2 in the second toss. So there are 2 ways in which you can get a 2 and a 5. So it's 2 divided by the total number of outcomes, 36, which gave 1 over 18. As opposed to the probability of getting a 2 then a 5. There's only one way of getting 2 then a 5, which was this case here where you get a 2 in the first toss, then a 5 in the second toss, which is what I showed here as one outcome, but it's easier to see when you write it out this way. So which is why it's 1 out of 36. But instead of carrying out this laborious approach, I just simply use the fact that the probability of 2 independent events, so getting a 2 in the first toss and getting a 5, so 2 then a 5, is simply equal to the probability of getting a 2 in the first toss and getting a 5 in the second toss. And the reason why I could use this formula was because I know that the result of the first toss is independent of the result of the second toss. So I can just simply multiply the probabilities to give the same answer. So here's another example question, and it says a coin and a single die are tossed simultaneously. They're tossed at the same time. What is the probability of obtaining heads or a 6? So you have a coin which is tossed, and there are two possible outcomes, getting a heads or tails for the coin. For the die, there are 6 possible outcomes. You can get 1, 2, 3, 4, 5, or 6. This question A is saying, what's the probability of getting a heads or a 6? So what I've done now is I've just tabulated all the possible outcomes. You can get a heads and a 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6. So what this is saying is, for the coin flip, if you get heads, you can get 1 for the die. Also, if you get heads for the coin flip, you can get 2 for the die, and so on. This row is considering the case where you get tails as the result of the coin flip. And it's saying you can get tails for the coin flip and 1 for the die, tails for the coin flip and 2 for the die. You can get tails for the coin flip and 3 for the die, and so on. So in summary, there are 12 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This question is asking the probability of getting heads or a 6. Getting heads or a 6. Now, the probability of getting heads or a 6 is simply equal to the probability of getting heads plus the probability of getting 6 minus probability of getting heads and a 6. Why? Because the result of the coin toss is independent of the result of the die toss. And you know, for independent events, the probability of A or B, where A and B are independent events, is equal to the probability of A plus the probability of B minus probability of A intersect B. So using that formula here gives probability of getting a heads or a 6 is equal to the probability of getting a heads plus the probability of getting a 6 minus the probability of getting a heads and a 6. What's the probability of getting a heads? Probability of getting a heads is simply as follows. 1, 2, 3, 4, 5, 6 divided by 12. So there's 6 ways you can get heads divided by 12 possible outcomes. What's the probability of getting a 6? How many ways can you get a 6? Well, there are 2 ways you can get a 6. You can get a 6 and then for the die, and you get heads for the coin flip, or you can get a 6 for the die and a tails for the coin flip. So there are only 2 ways of getting a 6 out of 12 possible outcomes. And what's the probability of getting heads and a 6? Well, there's only one way, heads and a 6. So one way out of 12 possible outcomes. So probability of getting a heads or a 6 is equal to 8 over 12 minus 1 over 12, which is simply 7 over 12. The second question asks for the probability of getting a tails or a 3. Now, this is basically saying what's the probability of getting a tails from the coin flip or getting a 3 from the die toss. So the probability of getting tails or a 3. Now, like I said earlier, the outcome of the coin flip is independent of the outcome of the die toss because they don't influence each other. Therefore, for 2 events which are independent, the probability of one event occurring or the other is equal to probability of A plus probability of B minus probability of A and B occurring. So this can be read as and or intersect. So probability of T, or well, getting a tails T or 3, which is 3, is equal to the probability of getting tails from the coin flip plus the probability of getting 3 from the die toss minus the probability of getting tails and a 3. Now, what's the probability of getting tails? Now, there are 12 outcomes, like I said earlier, and you can see them all here in the rows or the cells marked in white. How many ways can you get tails? There are 6 ways. 1, 2, 3, 4, 5, 6. There are 6 outcomes with tails. Out of how many outcomes? 12. So 6 over 12. What's the probability of getting a 3? How many outcomes have 3s? This one and this one. So there are 2 ways of getting a 3 out of 12 possible outcomes. minus the probability of getting tails and a 3. There's only one way you get tails and a 3. Tails in the coin flip and 3 in the die toss. One way out of 12 possible outcomes for the event, which is the die, the toss of the die and the coin. Therefore, probability of getting tails or 3 is given by 8 over 12 minus 1 over 12, which is also 7 over 12.